Imagine there are two friends, Dan and Sarah. Dan wants to send a secret message to Sarah and he doesn't want anyone to alter or make changes to that message. And Sarah, on the other hand, wants to ensure that the message she receives from Dan is 100% from him. Now, Dan remembers he has two keys, a private key and a public key. Dan also previously shared his public key to Sarah a couple of days ago, so Sarah has access to his public key. Knowing this, Dan begins to prepare his letter to Sarah. But first, he has to format his letter in a way that she'll be able to tell if someone altered it while in transit, and she'll also be able to tell that the letter is 100% from him. Now, the first step Dan takes is to pass his message through what is called a hash function, and this outputs what is called a message digest. Now, with this message digest, if Dan's message is altered when the letter is in transit, Sarah will be able to tell. The next step Dan takes is to ensure that Sarah will be able to confirm that the message she receives is 100% from him. Now, Dan uses his private key to encrypt the message digest that was created, and this outputs his signed message, which is the digital signature. Now, Dan's letter with his digital signature is ready to be shipped and sent to Sarah. When Sarah receives Dan's signed message, she will go through two phases to extract the message digest. She will verify that this message is from Dan by using Dan's public key to decrypt the digital signature and extract the message digest. In another step she takes, she passes the letter with the digital signature through that same hash function Dan used, and this produces the message digest. Now, Sarah compares the message digest values, and if they are equal, then she has confirmed that Dan's message was not altered while it was in transit. Now, Sarah is able to read Dan's secret message without worries of whether some weirdo altered it or if the message is really from Dan. And that is basically how digital signatures work.